talk about slope. Slope is the steepness of the line. And the way that works is the higher the number, the more steep it is. So a slope of like a half is really flat, whereas a slope of 5 would be really steep. Okay. The slope-intercept form of a line is y equals mx plus b, which I know you've all seen before. Whereas m is the actual slope, and b is the y-intercept. And the y-intercept is just where it hits the y-axis. There's a couple ways to calculate slope. We can count it if we have an actual picture, which is what we're going to do here. And slope is the rise over the run. And the way you can remember which one comes on top, you have to rise before you can go running, right? You have to get up. You can't just be sitting in your chair and go running, right? You have to actually get up first. So you have to rise before you run. So rise over run. And to calculate that, if you're given numbers, we do the 2 y's and we subtract them, and we can take 2 x's and we subtract them. And the x's and y's represent points on the line in the coordinate plane. So we can find the slope of this line and find the equation of this line using either 2 points on the line and calculating the slope through the equation, or we can just look at the picture and we can count the slope. I like to look at the picture and count the slope. It's nice that way. So to do that, the first thing we want to do is we're going to start by gathering the information that we'll need, not only to find the slope, but also to fill out the equation. So we're going to look for the y-intercept first. So step 1 is going to be to find the y-intercept. Okay. To do that, we go down the y-axis until we find the point where the line hits the y-axis. That's my y-intercept right there. The y-intercept is b, and in this particular case, it's hitting at -1, so b is equal to -1. The next thing I want to do is I want to move along the line until I find my next point. Now, the slope is going to be either positive or negative. On rise, we can go up or down. We'll just call that up or down. If you always move the way you read, so from left to right, then up is positive and down is negative. And that's a really easy way to remember which is positive and which is negative, because up, it makes sense, right? Up would be positive and down would be negative. And then moving from left to right, the way you read is very natural, because that's how we learn to read. Unless you are from some Asian countries and then you read the other direction, but we read left to right. So we're going to read the graph the same way we would read a book. So we start at the left and we move to the right. So starting at that y-intercept, we're going to move right along the line until we find the next perfect point. And the next perfect point is where it crosses right in the corner of the squares of the graph paper. So starting here, we're moving up, and then you can see right there it's crossing perfectly. So that's our next perfect point. So that's step 2. So move along the graph. So what we've now found is the y-intercept, which is our starting point, and our next perfect point is our destination. Okay? And then you think of the graph paper as like a grid of city streets where the white squares in between are buildings. So I want to go from here to here, but I can't walk along the line because I can't walk like through the buildings that way. So I have to take the streets. And the lines represent the streets. The lines on the graph paper represent the streets. So what I'm going to do is I'm going to go from here to there. And to find the slope, I'm going to count how many spaces that is. So I'm going to go 1, 2, 3, 4 spaces up. So I went up 4. Okay. And then I go 1, 2, 3 spaces to the right. So I'm going over 3. So like you went north 4 blocks and then east 3 blocks. Get from one place to the other. This represents our slope. We found our slope right here. Up or down comes first. We went up, so it's positive. So hold on a second, let me write that. Okay, we found those. We went up 4, and then we went over 3. This is our slope. So m is going to be 4 over 3. If we had to go down 4, it would be negative 4 over 3. So far okay? All right, so our slope is 4/3. Our y-intercept is -1. And so our last step is to plug those in. So we have y equals mx plus b, we have m and we have b, so we get y is equal to 4/3 x minus 1. This is the equation of this line. So first thing again, we're going to look, we're going to come down until we find our y-intercept, which is here. Then I'm going to go from there and I'm going to move along until I find my next perfect point, which is right there. Then I'm going to travel from here to there on the roads. And I went 1, 2 spaces down. So down 2 and then 1 space over. In this instance, my y-intercept was -1. My slope, I went down 2, so it's -2. So if you go down, it's negative. Over 1, and anything over 1 is just itself, so it's just 2. -2, rather. And if I plug that into the equation, I get -2x minus 1.
So going to the right is negative?
No, going to the right, if you always go to the right, up is positive and down is negative. As long as you always go to the right. If you go to the left, it's backwards and up is negative and down is positive.
So left and right don't
No, it does matter.
Imagine you're looking at a graph like yours are going down, and those are kind of like
Okay. So if you always move this direction, if you always move that direction, up is positive and down is negative. If you start moving backwards, it flips. So it actually makes everything backwards. Does that make sense?
Yeah.
Okay. So if you just always remember to go that way, then up is positive and down is negative as it should be. I'm going to go ahead and show you how on this same graph we could have done it using the algebra, the equation. And we get the same slope. We're just going to find slope this way, not the whole equation, just the slope. So if I want to find just the slope, and I have a picture and I forget to count it, but I remember the equation, I can use any 2 points anywhere on that line and still find the slope. So I could say, well, here's a point right here, and here's a point way down here. And I could use those 2 points if I want to. I just have to find out what their coordinates are. So this point here at the top is -2, +3. So that's -2, 3. And this point down here is +2, -5. Okay. So I'm going to use the slope equation I decide one of these points is 1s and one of them is 2s, and it doesn't matter which is which. Which one do you guys want to be the 1s? The -2 or the +2? +2. Okay, so this will be x1, y1, and that'll make this x2, y2. So I plug those in, and I get 3 minus -5 over -2 minus 2. The minus stays the same. This is the y2 minus y1, x2 minus x1. So I get 3 plus 5, which is 8, over -4, which gives me my slope of -2. So that's how you would use the equation, or if you were given 2 points to find the slope. Okay, just plug them in. Now, we have some special lines. We have a horizontal line, and we have a vertical line. And if we have a horizontal line, we have a lot of right and left happening, but not so much any up and down. Which means our up and down would be 0. And so that would put 0 up on the top of the equation, and 0 on the top of the equation is okay, because 0 divides by everything. And our slope of a horizontal line is always 0. So if you have a flat line, your slope is 0. And the equation of the line, because we don't have an x part because of the, it's y equals mx plus b, but m is always 0, so it just takes the x away, so it's just y equals b. So y is going to equal a number, and that number is going to happen to be where it hits the y-axis. We're hitting the y-axis here at -4. So the equation of this line is going to be y equals -4. So a horizontal line is always going to be y equals a number. And the number will always just be where it hits the y-axis. And we have a 0 slope. Now if I'm a vertical line, I have a whole lot of up and down happening, but no right to left, which makes my denominator 0. And is my denominator allowed to be 0? No, right? Because I can't divide by 0 because that's illegal. So if you have a vertical line, your slope is undefined. It doesn't exist. Now I'm not using the word no slope because people can misunderstand whether no slope means that the slope is 0 or whether it means that it's undefined. So we're going to stick to 0 and undefined to make sure that there's no confusion. So horizontal gives you a 0 slope. Vertical gives you an undefined slope. And because we're undefined, we take the y's away. And so this line, if you have a vertical line, is always going to be x equals some number. And that number is going to be where it hits the x-axis. this case, we're hitting at 3. So the equation at this line is x equals 3. If our slope is positive, okay, as we move this way, we're going to go up as the slope goes up. If our slope is negative, we go down. So that's another way to just double check yourself if you're asked to find the slope is you can look at the picture, and if you have a negative number but your slope picture looks like this, first one, it's going up, so it's supposed to be positive. If we have 0 slope, we're completely flat. And if we're undefined, we're straight up and down. Slope and rate of change are the same. The concept is the same. It's just how much something's changing over time. So something could be going up over time, or it could be going down over time, or there could be no change and it's horizontal over time, or there could be no time and it's completely vertical, and it would be an undefined rate of change. So we can use the slope as rate of change to predict things. So we are flying from Columbus, Ohio to Orlando, Florida, and after half an hour, we are 620 miles from Orlando. And then half an hour later, we're 450 miles from Orlando. And then we want to know, let's see, how far from Orlando are we 1.25 hours after we take off? So we need to find the rate of change, like how many miles are we traveling for that time frames of hours, right? So I'm going to take the time and the distance from Orlando, and I'm going to make myself a little T-chart to sort of organize everything. So our first time is half an hour, and we are 620 miles away. And then half an hour later, so we're half an hour and then half an hour later, so we're 1 hour. At 1 hour, we are 450 miles away. And we want to know how far away are we after 1.25 hours. So I'm going to find the slope. And I'm going to use the slope formula to do this. And I'm putting y's and x's up here, and you're going, yes, but you've got d's and t's on your chart. Right? Confusing? Time is always x. In any equation or any application, because x is always your independent variable, and time is independent, right? We have no effect over time. Time is going to happen whether we're doing anything or we're not doing anything. Correct? So time is always going to be x. So I'm going to turn that into an x, which makes this a y. So distance will be y. So I can say that this is x1 and this is x2, and this is y1 and this is y2, and I can plug those in. So I have 450 miles minus 620 miles over 1 hour minus half an hour, and I have 300, no, wait, all right, hold on. No, 170. Yeah, 170, sorry. I was getting ahead of myself and putting the other answer in. Yeah, it's negative 170 over 0.5. And this is not okay. Decimals are not allowed to be inside fractions. We don't like that. It's ugly and nasty and gross. So I'm going to divide my 170 by 0.5. And I'm going to get negative 340. And what this is telling me is I am getting 340 miles closer to Orlando every hour. Okay. Now, I want to know how far away I'm at 1 hours. Huh? That's it's actually it's distance. Yes, 340 miles every hour that you're traveling towards Orlando.
So that question mark could be filled in.
Not yet, because that's at every hour, but we want to know how far are we from Orlando in an hour and a quarter. So we need to figure out how much are we traveling in a quarter of an hour, because we know the distance at 1 hour. So we want to know if we go one more quarter of an hour. Does that make sense? So I'm going to take that 340 and I'm going to divide it by 4, because there's 4 quarters in an hour. And I'm going 85 miles every quarter of an hour. So I'm at 1 hour, I'm at 450. So at 1 1/4 hour, I need to take that 450 and subtract 85 from it. And I will be 365 miles from Orlando after 1 1/4 hours. Okay, here's another example where we're going to, we're actually going to draw a graph on this one. So, in 2006, 500 million songs were legally downloaded. In 2004, 200 million songs were legally downloaded. So, those are our data points. Use the data given, not the date given. Okay, to graph the line that models the number of songs. So, and as should only be in there once. Okay, anyway, we've got time, years. Again, time is x. So I'm going to put years across the x-axis, which is the bottom, and I'm going to put the millions of downloads across the y-axis, which is the top. And I'm going to start with 2004. Oops, not 2004. I mean, yes, 2004, but not yet. There were 200 million, right? Yeah, 200 million. So I'm just going to say this is 100 million. Actually, we'll do 51, 50, 200 million, 53, 50, 400 million, 600 million, 800 million, okay? And then across the bottom, I'm doing mine on 2 lines to give it more space in between 06, 07, 08, 09, 10, okay? Yeah, space out. So in 2004, there were 200 million songs, so that goes here. And in 2006, there were 500 million songs, so that goes here. And then I get this line. Okay. And if it's straight, I could just look at the picture. So if I had actually used a ruler, I could just look at the picture and find out, come up along the 2010 line and figure out what that number is, and I would know that it was good if I had drawn the line straight, which I did not. So I can't use the picture. So I'm going to find the slope of the line. So for B, oops, wrong pen. For B, I'm going to find the slope of the line. I'm going to call is x1, y1, and it's x2, y2. And I have y2 is 500 million, y1 is 200 million, x2 is 2006, and x1 is 2004. So I get 300 million divided by 2, so that's 150 million a year. So that's my interpretation, is that every year there's an extra 150 million more downloads as it's increasing in popularity. So if this trend continues at the same rate, how many songs will be downloaded in 2010? How many years between 2006 and 2010? 4, right? So I'm going to do 150 times 4 years. Is it 600? No, this is 600. 600 million. Okay, so that's the change. There's going to be 600 million, but we started out with, in 2006, how many? 500 million. So this is the 4 years plus the 500 million original. Well, we don't really say 1100 million, so I'm going to actually put in the extra zeros. And we've got 1,100,000,000 songs have been downloaded in 2010, had this trend been accurate. No, legally downloaded. So this is the official wordy postulate here. We have two non-vertical lines are parallel if and only if they have, have the same slope if and only if they're parallel. So basically, parallel lines have the same slope. Okay. 2 is parallel to 2 if the slopes are 2. 1/2 will be parallel to 1/2. All vertical lines are parallel. They're all going straight up and down, so that makes sense. Perpendicular lines. 2 non-vertical lines are perpendicular if the product of their slopes is -1. And when you have a horizontal and a vertical line will always be perpendicular, but this part, the product of their slopes is -1. What exactly does that mean? And what that means is that perpendicular slopes are negative reciprocals. Okay, so the slopes are opposite and upside down. So a slope of 3 is perpendicular -1/3, opposite and upside down. Or a slope of -2/3 will be perpendicular to +3/2. So here you've got 2 is parallel to 2, or 1/3 is parallel to 1/3. They have to be the same to be parallel. To be perpendicular, they have to flip over and have the opposite sign. So you have to be opposite and upside down to be perpendicular. Or if it's easier, you can remember that they are negative reciprocals of each other. But if I multiply these two things together, I would get that -1. Okay, we're going to decide if these points are parallel or perpendicular or nothing. Because that's what you are. You're parallel, you're perpendicular, or you're nothing. So we got our slope formula. That's a little sideways, but if I call this point's A, x1 and y1, and point B can be x2 and y2 for this line. So I'm going to have the slope of line M. So I have -5 minus 1 over -1 minus 1. So I have -6 over -2, which gives me a 3. Okay, so the slope of line M is 3. And for line N, I can call this x1 and y1, and this x2 and y2. And I can find this slope, and I can say 1 minus 2 over 6 minus 3, and I get -1 over 3, so -1/3. So I have 3 and -1/3. So they're definitely opposite. One's positive and one's negative, and they're flipped. So these two lines are perpendicular. Does that make sense? And then if I come here, x1, y1, x2, y2. So 0 minus 13 over -11 minus 14 gives me -13 over -25. And those are both negative, so it's positive 13 over 25. And this is x1, y1, x2, y2. So line M, I have -5 minus 7 over -4 minus -3, so I get -12 over -1, so I have 12. I just double check myself. Yep, those numbers are good. Those numbers are good. I have 13 25ths and 12. So those don't have any kind of relationship. They're not nothing. They're not parallel. They're not perpendicular. And then finally, I feel like purple. Line M, I'm going to have 2 minus 6 over -9 minus 3, which is going to give me -4 over -12, which is going to give me, oops, 1/3. Because they both divide by 4, and they're both negative. And fusion. And I have 3 minus 4 over 2 minus 5, which gives me a -1 over a -3, which gives me 1/3. They're the same, so these two lines are parallel. Okay, so how do we graph a line? We want to graph a line that contains some point is perpendicular to a line containing this other point. So first I'm going to find the line of that I want to be perpendicular to. I'm going to find that slope first. So I'm going to use these two numbers to find the slope. And so I'm going to do 0 minus -3 over 2 minus -2. And I'm going to get +3 over 4. So that's the slope of this line CD. So I'm going to go ahead and I'm going to graph it just to have it. C, D. Okay, so that's the line CD, and I want to be perpendicular to that line. So my perpendicular slope is on +3/4, and I want to be perpendicular. Perpendicular is going to be -4/3. Okay. So I'm going to find this point. -3, 0 is right here. Oops, I'm in my here that's going to be perpendicular to this. And the slope I want for that is -4/3. So I'm going to go down 4 and then over 3. So 1, 2, 3, 4. How did I get -4/3? This is the slope of this line. And if I'm perpendicular, I want to be opposite and upside down. So it's positive, so now it's negative, and then I flipped it. Does that make sense? So then I find the point A and then count down 4 over 3, draw my other point, and then that would be perpendicular. So this is the line that's perpendicular to the line that they gave me. If I, was using rulers and everything is perfect. Okay. If I go to QR, Q is -6, -2. Oops, remembering where I am. Yeah.
Go back over there on the blue line, on the blue hookups. What is it? The last one on the bottom?
Here.
The blue one? Dot?
Here.
The dot?
Here.
Yeah.
That's the point that I got to when I went down 4 and everything.
So that's when you did the connecting.
Yeah. Yeah, I just counted to that point. Why are you doing this? I don't want that. Go away. Okay, so, why are you doing this? Go away. Okay, so this is that QR, and I want to draw a line parallel to that. So first I'm going to find the slope for Q and R. So I'm going to use this and this, and find the slope. So I have -6 minus -2 over 0 minus -6. So I said this was x2, y2. So that's -6 plus 2, so that's -4 over +6. So that's -2 over 3. Because I multiplied by 2. And I want to be parallel. So my parallel slope is going to be the same. Okay, so I'm going to go to point P, 0, 1. And from there, I'm going to go down 2 and then over 3 because I want to use the same slope. So down 1, 2, and then over 1, 2, 3 to right there. And then this line will have the same slope as that line, so they'll be parallel.